Everybody. Yesterday I was talking about the factor label method of converting between units from units to other units. So whether that's distances, volumes, masses, even if we're trading animals back and forth, which is one of the examples I gave you, you can use factor label to figure out exactly how much of something you need to equal up to something else. Now, this is a chemistry class, and I would be a little amiss if I was not teaching you how to apply this directly to chemistry. And so the first thing I'm going to go ahead and point out is that factor label is a great way to deal with really complex chemistry problems. Not only in this class, but if you wind up going on into college chemistry, you will be using factor label to solve a lot of problems at that level. Now, if you're not planning on going on to college chemistry, factor label is still a great skill to have if you're trying to convert from one thing to the next. So, talking about specifically chemistry, take a look at the following balanced equation. I've got two hydrogens plus one oxygen becomes one molecule of H2O. And you'll remember that these numbers up front right here are what we refer to as coefficients. Now, the coefficients tell me how many of the atoms I'm going to need to make this equation be balanced on both sides, because we can't just create atoms out of thin air. Now, what we're really looking at is that these large numbers indicate how many moles of something we have. And so that's spelled moles, just like the little animal. And in chemistry, a mole is a certain amount of a substance. It's talking about a certain number of atoms. And because not all atoms are the same size, a mole of hydrogen has a very different weight than a mole of oxygen, because oxygen is a much larger atom. But a mole is kind of our functional unit in chemistry for how we get things done when we're comparing two different things. And so once we have our balanced coefficients, like our 2, our 1, and our 1, we have what we refer to as a molar ratio. And the molar ratio is how we'll be able to apply factor label to chemistry. So the molar ratio gives us a way to predict how chemical reactions work in the lab. And when we take a look at the periodic table, you'll see in this example on the bottom here, we've got this 18.998. This is the mass of 1 mole of fluorine. So in 1 mole of fluorine, the molar mass is 18.998. And that's another thing that I pointed out last semester. So here's an example of how I would start using that in a factor label example. Here's an equation right here. 2H plus O is equal to H2O, the exact same equation I gave you on the previous slide. Remember, if there's no number in front of a chemical, really there's secretly a 1 here. So I've got 2 hydrogens plus 1 oxygen becomes 1 molecule of H2O. Now, I've also gone ahead and given you the mass of hydrogen is 1 gram per mole. The mass of oxygen is 16 grams per mole. If you were looking at your periodic table, that's the number that shows up on the bottom here. In fact, on the big periodic table in my room, it's in red. So, if a chemist has 48 grams of hydrogen and an infinite supply of oxygen, how much water can be produced? So just like in factor label, the first thing we're going to do is take our opening number and put it over 1. So we have 48 grams of hydrogen. We'll put that number over 1. Now the next thing we need to do is multiply it by how many grams of hydrogen are in 1 mole of hydrogen. So I can take a look up here. I can see that for every 1 mole of hydrogen, there's 1 gram of hydrogen, and that's great. As you can see, our grams of hydrogen will cancel out right here, and we're on our way. So now we've got moles of hydrogen. And if we take a look at our coefficients up here at the beginning, you guys can see that if I have if I have 2 moles of hydrogen, I will get 1 mole of water, H2O. Moles of hydrogen cancel out. Move on to my next step, because I'm looking for how much water. I'm probably going to want this to be in grams. I probably should have been more specific about that. So in 1 mole of water, H2O, I've got 2 H's, so that's 2 grams, plus 1 O, which is 16 grams. I will have 18 grams of water. And so once again, moles of water will cancel out. I am left with grams of water as my last unit, which is what I was looking for. So now in order to solve this problem, I will take 48 times 1 divided by 2 times 18. Just a reminder, I multiply things that are on the top, I divide things on the bottom, and you guys should be able to solve that one fairly well. It's going to wind up being 24 times 18, whatever that is. And that will be, if we can see our units right here, this is going to be in grams of water. So this is how we solve an equation similar like this in chemistry. Let's take another look at another example. This one's slightly more complicated. I've got methane here, or wait, I've got propane right here. Combining with oxygen, it's an explosive reaction, but it produces carbon dioxide and water. And once again, I have the molar masses already listed for you. And this is a balanced equation. So if I have 46 grams of C3H8, put my first number over 1. I know I have to have grams of C3H8 on the bottom. And so C3H8 is going to be a total of 44 grams per mole. You can get that by simply taking, I'll write that up here, 12 times 3 because I have 3 carbons, plus 8 times 1 because I have 8 hydrogens, so C3H8 is going to give me a total of 44 grams per mole. Sorry about writing that on the outside, but I need to save my space. So I've got 44 grams of this, so this will cancel, this will cancel. And I have, how many of those molecules? I have 1. That's going to be 1 mole C3H8. Next up, I can go to my molar ratio. I've got 1 mole C3H8, and for every 1 mole, I get 3 moles of CO2, which you can find there's secretly a 1 right in front of here. Here's the 3, so that's why I have 1 mole of CO2. One more time, moles cancel right here. I have, sorry, this is moles. And then finally, I can go for every 1 mole of CO2, so these will cancel out. I have 14 grams of CO2. So you can quickly do the math on this one. 46 divided by 44 times 3 times 14, and that will get you something. Our last unit, which I haven't canceled out, is going to be grams of CO2, and then you'll have a number. So that's how we apply this to chemistry. It does get a little bit more complicated, and I'm going to tell you right now, it takes practice, and we will have plenty of time to practice this skill before you have to reproduce it on a test. If you need to, go back and watch this video over again. If you think you're ready for it, this is the practice I would like to give it to you. I've already balanced the equation for you. You can see that right here. The molar masses are given in this line right here, which you can use. And if I don't specifically mention anything, just believe that it's in excess, which means it's not going to limit the reaction and everything's going to go through perfectly. Here are the 3 questions I would like you to answer in your notebook, and I will see you in class.